All right, so we're going to wrap up this semester talking about similarity. Chapter 6 is all about similarity. Now, similarity is almost like congruent light. Similarity is same shape, but not necessarily the same size. But the sizes do need to be proportional, and we'll talk about that more as we get into different figures and things like that. For now, we're going to start off doing a little bit of review on ratios, proportions, and introducing something called the geometric mean. Okay, so by the end of this video, you should be able to set up and simplify ratios. You should be able to use ratios for different applications. We need to be able to solve proportions and set them up to help us solve for different real-life situations. And then talk about the geometric mean and how to find it. Okay, so first things first, ratios. If you're going to simplify a ratio, well, first, you see over here, a ratio is a comparison of two numbers written as. And there's two different ways you can write a ratio. As a fraction, so A to B is how you read that, or with a colon. And you read that the same way, A to B. We're comparing A to B. And that's what we need to make sure we remember a ratio is. It's a comparison between two measurements, right? And a ratio is designed to let us know how much bigger one measurement is than another, okay? And since we're just trying to find out how much bigger one measurement is than another, then we don't need units. Ratios tend to be unitless. And so we have to make sure that we create our ratio or set it up to where they have this, both measurements are in the same unit, so those units will divide out. I'll show you what I mean in just a second. And we need to simplify it down as far as we can. The more simplified a ratio is, the more meaning it has. Okay? So for example, if I want to know how much longer 64 meters is than 6 meters, right, then I can rewrite this ratio as a fraction, 64 meters to 6 meters. And I do that, the meters will divide out, so now we're unitless. And so all I got to do is reduce that fraction. Now remember how we reduce fractions? What do we do when we reduce fractions? Well, we divide a common factor out. Since both of these, since both the numerator and the denominator are divisible by 2, right, we're dividing out a common factor to reduce it. And that common factor, once we divide it out, reduces this guy to 32 over 3, which is as far as we need to simplify our ratios. Okay? Now, it doesn't really give us a much clearer picture about how much longer 64 meters is than 6 meters, but it's closer. What we could do is go ahead and divide the numerator and the denominator by 3, and get 10.67 in the numerator and 1 in the denominator, and try to get either a numerator or a denominator to be 1. Because now what this would tell us is that 64 meters is 10.67 times longer than 6 meters. And that has a little bit more meaning. But very often we'll just reduce our ratio as far down as we can using common factors and leave it at that. Okay? Now, to find out how much longer, or even to know if 5 feet is longer than 20 inches, right? We want to reduce this guy down. Now, we don't want to just go ahead and make this 1 to 4, because what that would tell us is that 20 inches is 4 times longer than 5 feet. That doesn't make any sense, right? So the issue here is they're not in the same units, and so it's not a real clear comparison. The other issue is I can't divide out common units because there aren't any. So our ratio would still have units in it. So what I need to do is I need to convert these over, right? I'm going to take 5 feet to 20 inches, and I'm going to use the conversion factor of 12 inches to 1 foot and multiply it by that conversion factor. Now when I do that, I want to place my units to where they'll all divide out. So if the inches are in the denominator over here, they have to be in the numerator in the second guy. And if feet are in the numerator of the first fraction, it needs to go in, the feet need to be in the denominator of the second fraction. And so I want to multiply 5 over 20 by 12 over 1, 12 inches to 1 foot. Now the feet will divide out. When I do that, I get 60 over 20. And I'm unitless now. There's no units here. Reduce this down by dividing both by 20, and we get 3 to 1. So instead of thinking that 20 inches is 4 times longer than 5 feet, I now look at this and know that 5 feet is 3 times longer than 20 inches. Okay? And read 3 to 1. Okay, so the moral of the story there is make sure that your ratio is in the same units before you start to reduce. All right? So you've got a couple of more here for you to try. So go ahead, take a couple seconds, try to reduce those ratios and see what you get. I'll show you the answer to make sure that you're doing it correctly. Okay, if you haven't gotten it done, stop the video real quick, work it out, finish working it out, and then start it back up. But 24 yards to 3 yards. Just write it as a fraction. Yards will divide out and reduce that down to 8 to 1. Okay? 150 centimeters to 6 meters. I can't just straight reduce. I've got to turn these guys. I got to use a conversion factor to make sure that I can divide out my units. 1 meter is 100 centimeters. So meters will divide out here, centimeters divide out here, and we get 150 over 100. 150 over 100. Reduce that down. To 3 to 2. Okay? And there you go. If it doesn't make a lot of sense, make sure you come find me. We'll discuss it. All right. How can we use the idea of a ratio? Let's say you're planning to paint a mural on a rectangular wall. You know the perimeter of the wall, but we need to know what the area is so that we know how much paint to get. Right? So now we don't know what the actual length and width is, but we do know that the ratio of length to width is 9 to 2. So here's what we got going on. We've got perimeter going on. Now perimeter is add up all the sides, and since there's 2 lengths and 2 widths, we can just add 2L and 2W. And we know the area is length times width. Okay? Now 9 to 2 does not tell us that the wall is 9 feet long and 2 feet wide. It just says that it's, if you were to write their measurements as a ratio, they would reduce down to 9 to 2, which means that they apparently have a common factor. But we don't know what that common factor is. So let it be x. And if that's the case, I can let the length be 9x and the width be 2x. And now I can use that in my perimeter formula. The perimeter is 484 feet. And I've got the length and the width. And now we're just solving. Right, add the 2 x's together there, we get 22x. Divide by 22, and x is 22. Okay, now if that's the case, then we know that our length is going to be 9 times 22, which is 198, and our width is going to be 2 times 22, which is 44. And now to find the area, we take 198 times 44, which is 8,712 square feet. So now we need enough paint to cover 8,712 square feet. Okay? So pretty nifty use for ratio there. All right? Same thing if you're going to talk about the angles of a triangle. Now there are things called extended ratios. An extended ratio is just like any other ratio. It's just comparing more than 2 measurements. We can compare as many measurements as we want to in an extended ratio. Now, what this lets us know is that these 3 angles of this triangle are in the extended ratio of 1 to 2 to 3, which means the same thing they did before. these three angles have a common factor, but we don't know what it is. Let that be x, and so we can multiply 1, 2, and 3 by x, and those become our angle measures, which is where these guys came from. Now, since they're angles of a triangle, we know we have to add these guys together. And when they do, they have to equal 380. Okay? Hi. All right, so divide by 6, and x is 30. So we plug it back in, and we get 30 degrees, 60 degrees, and 90 degrees. Okay? All right. Got a couple more problems in your notes there, so go ahead and take a look at those. See if you can't figure out how to work those out. Stop the video, start it back up when you're ready, and you can check your answers. All right, so what did you come up with? Okay. Here, the length and width of the room are going to be 14 feet and 10 feet. If you can't get there, make sure you come find me and we'll discuss it. And in the next triangle, you should get 20 degrees, 60 degrees, and 100 degrees. Again, if you don't get that, make sure you come find me and we'll talk about it. Okay? All right. Now, we're getting into proportions. Okay, some quick vocabulary for you. A proportion is an equation that states that two ratios are equal. Okay? It's really important that we remember that because we're going to use that idea quite a bit. A proportion is an equation that says that two ratios are equal. So letting us know that this ratio equals this ratio. Now, if we're missing something, if we're trying to find out what number fits in there to make those two ratios equal, we're just going to solve by cross multiply. So what that means is when we multiply our two diagonals, those guys are going to be equal to each other. So, for example, this first guy here, right? We're going to multiply 5 times 16 to get 80, 10 times x to get 10x. And so what I'm trying to find out is what value of x would make these two ratios equal. 5 to 10 would be the same as comparing what number to 16. And it might be easy enough to sort of think through it and figure it out, but by the methods of solving a proportion, we find out that x can be 8. X is going to be 8, and those two ratios would be the same. A little more complicated example here is not quite so easy to see right off the bat. Is letter B here. Same process, cross multiply. When I do, those two products are going to be equal to each other. Another thing here is make sure you distribute that 2 to this denominator here. Right, now subtract 2y from both sides, and y ends up being 2. So if y is 2, then those two ratios would be the same. Okay? Should be some review for you, so there you go. Right, now, same deal here. 5, 6, and 7 are in your notes. Give those a shot, solving those, and check your answers. Stop the video, check your answers, make sure you're doing them right. Okay, number 5. You should get 16 over 5, or if you divided it out, that's perfectly fine if you did. It probably even makes more sense to do that. You should get 3.2. Okay, number 6 is 12, and number 7 is 6. If you didn't get those answers, two things I would check. First of all, make sure you're distributing this 4, so you should get 4x minus 12 when you multiply there. And then make sure you're distributing this 14. You should get 14y minus 42 here. If you did that and still didn't get 12 and 6, come find me and we'll discuss why. Now, how can we use proportions? Remember, proportion is supposed to let us know that these two ratios are equal. So as part of an environmental study, you need to estimate the number of trees in a 150-acre area. You count 270 trees in a 2-acre area, and the last thing you want to do is count more trees in a 150-acre area. But we can assume that the trees are going to be evenly distributed. If that's the case, then the ratio of trees to acres, whether it's 2 acres or 150 acres, should be the same. And we can use that to help us estimate the total number of trees. So what that means is, if there are 270 trees in 2 acres, and the trees are evenly distributed, then we should be able to find out how many trees are in 150 acres by setting that equal to x to 150. Okay? Now when we cross multiply, we get 2x equals, quick calculation here, $40,500 divided by 2, and we get 20,250. And so we can assume that there are 20,250 trees in the 150 acre area, and we can use that information for whatever we need to. Okay? Now, with proportions, there are a couple of different ways we could set that up and still get 20,250. We'll discuss that as we need to, the different properties of proportions. Okay? But there's one way to set that up. Okay? Now, okay, continue laying the foundation here. We'll talk about the geometric mean. Okay? The geometric mean is different than the arithmetic mean. The arithmetic mean is just the mean that you've always known. Right? Arithmetic mean is you add the numbers and divide by 2. So if we were to add 24 and 48, we'd get 72, and divided by 2, and you get 36. The geometric mean is different. It's not the middle number necessarily between 24 and 48. What it is it's a positive number, or it's a number that for two positive numbers, a and b, that the geometric mean would satisfy a proportion written with a and b. And so it's a way for us to see that a and b are proportional, are in a certain ratio, that kind of thing. Now, as you can see, when you solve this proportion, you're going to cross multiply still and get x squared equals a times b. And that's where this guy right here comes from, because when you square root both sides, you get the square root of a times b. So instead of adding the two numbers divided by 2, you multiply the two numbers and square root them. Okay, so you're going to find out this is going to give you a very different result. So if I want to find the geometric mean between 24 and 48, right, I want to set this up as a proportion. I want to set the proportion up. So for every geometric mean, set your proportion up, okay? And then cross multiply. Yes, I know you can just multiply the two numbers together and then square root. But there's going to be a reason why we're setting these proportions up, okay? Now, we get 24 times 48, which is 1152. And now we got to square root that. Now, you're not going to type this in your calculator and give me some weird decimal answer. What we need to do is get good at reducing our radicals. Okay? So we need to reduce this. And I think the easiest way to reduce this is to find the biggest perfect square number that will divide into 1152. Now, what's a perfect square number? Perfect square numbers are numbers like 4, 9, 16, 25, 36, 49, 64, 144, so on and so forth. These are numbers that we can square root and get a whole number. Okay? I need the largest perfect square number that will go into 1152. Now, you can just start trial and error. 1152 divided by, let's try 144. When we do that, it will go into it 8 times. So I can rewrite this as 144 times 8. Now the reason why I do that is because I can square root 144 and get 12, and when I do that, 12 comes outside the radical. And I'm still going to have 8 in. Now, 8's not done. 4 will go into 8. So I can actually rewrite this as 12 square root of 4 times 2. And then square root the 4 and pull it back out. Square root of 4 is 2, so I get 2 times 12, which is 24, square root of 2. As a way to remember how to reduce your radicals. Algebra 2 and pre-calc will want you to be able to reduce your radicals, so that's why we're doing that here. Okay? So we gotta get good at that again. But that's your geometric mean, which is very different than your arithmetic mean. So for right now, set your proportion up and go solve that. Okay? Now, you've got 3 sets of numbers to find the geometric mean for. Go ahead and do that. I'll show you the answers to make sure you're getting that. All right, so you should have gotten 18 for 9, 18 radical 3 for 10, and for 16 and 18, I thought I had the answer ready to go, and apparently I don't. So let's do this real quick. Right, so we're going to go 16 to x equals x to 18. Cross multiply, we get x squared equals 288. I happen to know that 144 will go into 288 twice. Square root of 144 is 12, so you should get 12 square root of 2. If you're not getting those, make sure you find me, and we'll discuss why and remember how to reduce radicals. Okay? All right, that's it. So homework's out in Canvas. Make sure you get that done and submitted. Okay?